We've done pHs of weak acids, but we need to do what? We need to look at pH of a weak base, don't we? Yes, we did. Remember how I started the weak acid and I said, oh, if you've got HA, it yields hydrogen ion and the conjugate base, the little generic thing? That's okay.
Just the same thing as the Ka?
Yes.
Same process?
Yes, it is. It's the same. It's very similar. There's just one little difference. Guys, ammonia is a weak base. Okay, so if I were to look at this reaction of ammonia with water, if I tell you ammonia is a base, then you know that that means it would accept a hydrogen. Where is it going to get the hydrogen from? From water. So what would that leave on my product side? Yes, wouldn't it be NH4 positive, aqueous, plus, and if it's going to take a hydrogen from water, it's going to leave water as the hydroxide. Won't it?
Can you have liquid hydroxide?
Ammonium hydroxide? No, you can't. Not unless it's under extreme pressure, low temperature. Because even when you have ammonia, cleaning ammonia, that's ammonia gas dissolved in water. It's actually ammonium hydroxide solution. It's the ammonia. It's the NH3 of it. Yeah, it does. Hang on, I have to pause it. Okay, so now that we got that out of the way. This is basically how any weak base would look. It's going to take a hydrogen from water, produce hydroxide ions in solution. Hence, that's what makes it a base, because it's got an excess of OH, and it would have a really high pH. Since this is an equilibrium reaction, then y'all know it would likewise have an equilibrium constant expression, wouldn't it? And it's going to be products over reactants raised to the power of the coefficient. But when I look at that, I do note that water is a liquid. What do I do with liquids in equilibrium constant expressions? I do not include them. So what this would look like is products, the NH4 times the OH, divided by reactants, which is the ammonia, whatever the original base is, and that's going to be equal to an equilibrium constant. Since this is a weak base, what designation do you think we're going to give that equilibrium constant? A Kb. Do y'all see that if we set up an ice table for every one of these problems, that we would end up with Kb is going to be equal to x squared divided by the initial concentration of the base minus x. So that's the same thing we had when we were using acids, except now it's a Kb. And we can still make that same assumption. What was that assumption? We can take out the x so that it's not even there. So Kb is equal to x squared divided by the initial concentration. It's a lot like a weak acid, except you have to watch. For a weak acid, like what we were doing when we started class, when we look at this weak acid Ka, x was equal to the hydrogen ion concentration, right? But when we're doing weak bases, what is x equal to? X is equal to the hydroxide ion concentration. Can you get from there to pH? Yes, you just have to, it takes one more step, right? If X is going to be equal to the hydroxide ion concentration, then the negative log of X is going to give you what? The POH, and then you would subtract it from 14 to get the pH. So there's this one little step in here. You've got to get POH first and then the pH. Okay? Let's calculate the pH of 0.12 molar ammonia. So I'll look up my KB, right? Page 695 tells me that the KB is 1.8 times 10 to the minus 5. I don't know what X is, but I know that the initial concentration of this acid is 0.12 molar. So when I cross multiply, and then I take the square root of it, what do y'all get for X?
1.47 times 10 to the negative 3.
Yeah, 1.47 times 10 to the minus 3, or Daniel, you said 0.00147? That's the same thing. Yeah, I just prefer scientific notation.
How did you get
For
to
me.
1.8 again?
Yeah. What is X? X is hydroxide. So, to get the POH, I can take the negative log of the X. And when I take the negative log of that, I'm remembering that times 10 to the minus 3 gives me a ballpark of what I should get, right? Since this is around 3, I know my POH should be near that. So for the pH, POH, I got 2.8. And then how did I get the pH? I said 14 minus that, and I get a pH of 11.2. All right, let's work another one similar to that. Let's calculate the pH of a 0.48 molar weak base which has a concentration, a KB equal to 2.1 times 10 to the minus 11. So basically, instead of asking you to look it up in the table, I'm telling you what the KB is. Go ahead and put up here how to work it. 2.1 times 10 to the minus 11 is equal to x squared divided by 0.48. Solving for x, get 3.2 times 10 to the minus 6. The negative log of that gives me the POH, which is 5.5. And 14 minus that gives me the pH, which is 8.5.